Now that we have defined the soft contacts on our contacts object, what we can do is to query the buffered dataset or the soft composites. In order to do that, we use the get buffered datasets function. For this function, we need to specify the variable. We need to provide the grid, and this grid must be flagged with the domain codes because the grid is used to define the buffering distance, and that buffering distance that's flagged back to the grid is used to flag the composites and then get the soft composites. We need to specify the domain column for the domain in the grid. In our case, it's just the same name. And sometimes there's a mismatch between the composites and the grid. We typically want to trust what's being flagged on the composites. So we set the reflag from model to false. Otherwise, if we do want to overwrite what we see in the composites, but by what we see in the model, we can set this to true. We do have an option to return the indicators as a result of this function, but we also typically set this to false, and instead we return a dictionary, and the key of the dictionary is the category code, and the values are the soft composites for that particular category code. So let's run this cell. Soft composites is the output of this function. This is a dictionary. We can take a look at the keys. Notice that the keys are the categorical codes. So 0 for the background or the outside domain, and 1 for the high-grade shell. And if we take a look at one of this data, in this case for code 0, we have added a column that's called soft data. So this column will indicate whether or not this data row is a soft data or if it is a hard data for that domain. So if it's false, it means it's a hard data. This data location was originally inside the domain. Otherwise, if it's true, it is a soft data. So it means that that data location was taken from another domain within the soft boundary. Now, similarly to when we looked at the impact of capping the data on the data statistics, we might also want to see the impact of buffering or the soft boundary on the data statistics. So comparing the hard boundary statistics to the soft boundary statistics. So to do that, we have another function, another utility that's defined on the parameter file. So let's take a look. So within the parameter file, we have this function. This function takes soft composites and the variable that we want to calculate the table for. And what we do is we select a subset of the statistics, just like we did for the capping. But in this case, we're only looking at the count, mean, and coefficient of variation. We are defining the index structure for the multi-index data frame the same way we did for the capping table. So we start with an empty list, and we append to the list each one of the statistics repeated twice in a size 2 list. And then we keep defining the list by including a second list where the first entry of that list is the list we just created. So that gets placed on the first entry, and we just repeat the keywords hard and soft for the same number of times as the number of statistics that we have. Exactly the same as we did for the capping, that the result of these lines of code will generate an array or a list of lists that has the structure that's required for pandas data frame to create the multi-index data frame. We do initialize the columns with the domain names so that we are calculating by domain. We iterate each domain code. We copy the data from that domain. We only need the two columns, soft data and variable, to do what we need. We calculate the soft statistics for all the data within the soft composites dataset using unistats. I have mentioned this function before. This is for calculating statistics for a single variable. In this case, we're just calculating for gold. And then for the hard boundary, we slice the data where soft data is false. So we have to reverse the Boolean case by using this symbol. So where soft data is false, it becomes true, and therefore we are getting the hard data for that variable. And we're building the statistics for the hard variable as well. Lastly, what we do is an extra loop over the hard and the soft statistics. So we're just zipping the names and the statistics, and we are accessing those as the name and uni for unistats. And inside this loop, we have another loop with the stat in stats. So basically the statistics that we have selected. So for each one of these statistics, we are getting that statistics from the unistats object and saving it to the table. So we are writing each row of the table, and then at the end we just return the table. So let's see the result of this function. Very similar to the capping table, where we have a multi-index data frame with count, mean, coefficient of variation for the hard and soft boundary, for the outside and the inside domains. So for the outside domain, for instance, we had 16,000 composites and the hard boundary. With the soft boundary, that's up to 19,000. The average has increased for the outside domain because we are adding data from the inside domain. So it has increased from 0.35 to 0.48, and the coefficient of variation has increased as well. For the inside domain, we had an increase in count from 5,000 to 9,000, and a decrease in the mean because we're adding data from a lower grade domain from 1.4 to 1.0, and the coefficient of variation has increased.